Okay, this video is for EE1106. What I have right here is a video capture going on in the lab. Today's lab is the solder lab. If you've gone to the website, you will see that the one thing that's part of the pre-lab is to, of course, read this solder kit handout and do a little bit of a Google search on some basic how-to videos of how to solder. Let's get to the solder kit itself. So the solder kit itself comes with this handout that it's in this PDF file. It's not a very well captured PDF file. It was scanned kind of poorly. What I want to get to first is page, what I want you to focus on is page 6. If you have never soldered before, read through this. When you get to page 6, it's got tips on actually practicing on this board. Okay, so solder practice, read this page very carefully. I'm going to get to it. I'm going to show you kind of the contents of this kit. And so here is the kit. I'm going to take all the parts out of it. Here are the parts all laid out. The board that we're going to solder is right here. It looks like this. The component side of the board is this blue side. That's where the parts are going to exist. You're going to bend the leads and poke them through these holes, and the silk screen on here, the white lines on here, actually show you where the parts go. There are the labels on there. It says R for resistors, C for capacitors. There's a potentiometer that goes right here as a volume control. There's an IC, a 555 timer. That's in the package in that little pink piece of foam stuck in there, that little chip there. There are some jumper wires. There's a jumper wire there that needs to go right there, and there's a jumper wire right there. There's some R's. Here are some transistors. They're actually 3-lead, 3-pin devices. And there are some LEDs. All of these, some of these, many of these are polarized devices, meaning it matters which way you turn the device, especially LEDs. And capacitors, the capacitors that have the plus and minus on them, you have to make sure you turn them correctly. Resistors are non-polarized, so it doesn't matter which direction you turn them. Certain capacitors, like the C5 and the C4 here, there's no plus and minus on the silk screen here, so it doesn't matter which way you turn those. So let's get a look at, look at some of these components. There is a paper strip with the resistors and the capacitors. So you can go through that as I take this out of the plastic. You can see there's a paper strip there, and they're just labeled they're labeled R3, R1, R7. So they're not really in order as far as numerical order. So be very careful as you take these off one at a time. I would very carefully populate the board. What you're going to want to do is trim these leads so that the resistors are actually sitting down on the component side, and then the leads will poke through on the solder side. So let's look at that. Let's look at the solder side of the board. Remember, component side, solder side. What you see on this solder side is kind of a dark green areas, and then these lighter green areas that look like lines going back and forth between the actual pads, those little silver discs where the terminals are coming through, terminals of the device are coming through, are called the pads. And that's where we're going to put solder, to actually solder the pins of the device to the traces. Those lighter green actually lines that you see, they're actually kind of underneath a plastic film there. So there's no electrical. If I actually probed right there in the green areas, I wouldn't get anything. But if I probe the pads from one place to another, I actually would get continuity. And maybe I should show that. Let's see. As we look at these traces, it looks like they're between this pad and then here and all down here. You can see where the trace underneath the plastic kind of follows in that line. And that indicates there should be connectivity between this point and this point. Let's see if that is the case. If I probe from here to here, from here to here, there's connectivity between all of those points. And that's on purpose. There is a copper trace, that lighter green line down there. Now from here to here, there's no connectivity. There's no green trace that continues from that point to that point. But these 4 pads are all electrically connected. And you can test that with any point. This looks like this pad and this pad are connected with a trace right there. Let's check. Indeed, they are connected. Okay, so you can probe around there and see the connectivity of the circuit by probing the traces with a continuity check. Now, to populate the parts, let's do the first one here. And I'm going to look for the first one in the strip is labeled R3. Okay, I know that doesn't focus very well, but the very first one there is called R3. I'm going to remove it from the paper. I'm going to find R3 here on my component side. It's right there. So I'm going to stick the leads there, and I'm going to bend the leads so that they obviously go through the hole. And the resistor on the component side, that resistor should be laying flat, just like I would expect it to lay flat on a breadboard if you were breadboarding these devices. And if we look at the other side, as it comes through the hole, I want to bend it out just a little bit, not flat down on the board, but out just a little bit so that as I hold it like this, it's not going to fall back through onto the table there. So the leads are just slightly bent out away a little bit so that the resistor will stay put. Now the proper soldering technique is to bring in a soldering iron right there so that it is actually touching the pad. That disc is actually a little physical washer that is soldered onto the trace. And what I want to do is bring in the tip of my soldering iron so I'm heating both the pad and the resistor lead, or the lead of the device, at the same time with the same amount of pressure, with the same amount of heat. Okay. So since we're talking about soldering irons now, let's talk about it. I have this soldering iron. I just turned it on, and it had been sitting for a while in the cabinet. So the tip of it, you can kind of see. I know it's kind of hard to see in this video, I know, but it's kind of dark, and it's oxidized is what it is. So what I need to do is clean it. My sponge on my soldering station is wet. So I should be able to just take this and wipe it. You'll hear the water in the sponge sizzle a little bit as I wipe it in the sponge. Probably can't hear that on the screen. But as I wipe that now, look at the tip is very nice and shiny. The reason it kind of wipes away that oxidation is because there's actually a layer of solder on this tip. And the key to soldering always is to keep a little bit of solder on the iron at all times. The solder that you're going to use actually comes with the kit. It's in a little tube like this. It's actually in a coil of solder. It bends very easily. This blue cap is on there, and you can thread the solder through this blue cap and then just kind of pull out what you need. So I want to pull out a few inches of it. And what I do to start this soldering iron, to kind of get it ready, I wipe it a little bit just to clean off the oxidation and put a little bit of solder on the tip. Notice it kind of bubbles up and the flux burns away, a little bit of smoke comes off. Try not to breathe that smoke too much, right? And then as I work with this tip, I'm going to now brush it actually very gently on my sponge, just to kind of wipe a little bit, but not all of the solder away. In other words, I want to keep the tip of the soldering iron wet with solder. I don't want to wipe it all away. If I wipe too much away, then it will just oxidize and it won't heat evenly. Okay, so I know it's hard to see here, but I'm going to come down to where that resistor lead is coming through that that hole on the solder side of the board. The idea is I'm going to bring the tip in, and I'm going to make contact with both the pad that's on the board and the terminal of the resistor at the same time. And I bring the soldering iron in first, heat both of those equally, and then bring the solder in after they're kind of heated a little bit. And I got to push the solder so that it melts in. And notice I push it in, and it kind of forms like a blob right there. Then I've got to pull the solder away first, and then pull the iron away. So the order is iron first, solder, then pull the solder away, and pull the iron away. And I don't know if I can get a close-up of that very well, but now there's a nice little peak on top of that pad, and I know that's not focusing very well. But that resistor lead is now soldered to the pad and making a good electrical connection between the resistor and the trace that's going to some other part of my circuit. So. And again, I know that's not focusing very well. We'll be able to see it in class a little better, and hopefully in some of the videos online tutorials they're doing a little better with their video camera. Okay, so that's the idea for getting that. Now, as you do that, go ahead and leave it long like that. Get everything done before you go back and actually trim the leads, because you might have to rework some of this. If you go in and you heat just the pad and not the lead, you're going to apply too much heat to the pad and it's going to pull away from the trace. It's actually going to disconnect. That little pad, that circular silver area, is its own part. It is a separate part. It's like a washer, very thin washer that's glued down on that trace. In other words, it's soldered down. But if you heat it too much and it lifts away, you're going to lose that electrical connection. So too much heat on the pad without heating the resistor lead or the device lead is bad. You've got to heat them equally, both at the same time. By the same token, if you heat the lead and you're not making contact with the pad with the soldering iron, you will get a big blob of solder on the lead, but it won't be connected to the pad. Again, you won't have an electrical connection. You'll have to rework it. So even the tip of the soldering iron should be in contact with the pad and the resistor lead equally, 50-50, with a little bit of pressure. You're pushing it into it with a little bit of pressure so they're heating evenly. You push the solder in so that it melts. You'll probably lose about a 1/4 inch, a 1/2 inch of solder as you push the solder in. You take the solder away first and then the iron. Okay? If you take the iron away first, the solder actually will cool and stick right there. You'll have the whole spool of solder stuck to your trace. You'll have to bring the soldering iron in to disconnect it. Now, that's a little bit of an advanced lesson. For those of you who have never touched a soldering iron, go back to that page 6 that explains about this practice area over here. So before you do anything, if you've never soldered before, and you don't want to start with those components because you don't want to mess them up, just go into this practice area and start putting down some little blobs of solder along here. That's what these practice areas are for. Notice there's no hole through there, so it's just meant to bring the soldering iron in contact with the pad and then push a little bit of solder in there. Pull the solder away first and then the iron, and you can do that over and over again. Just practice that. Okay. Watch the smoke coming up. You don't want to inhale that stuff. It's not good for you in general. I can just do that over and over. Now, in between doing that soldering, you should come over and give your soldering iron a little bit of a wipe. Just wipe the dirt away, keep it clean. It should be nice and shiny. As you're doing this, you can put a little bit of solder on there and give it a gentle wipe. Again, I'm not trying to wipe all the solder off. I'm not trying to take everything away. I'm just trying to keep it just with a little thin coat of soldering. Okay. So again, I'm bringing that in. Again, my camera's not focusing well, but I'll bring this board up and show you what I've done here. Let's see if I can do that. So there's a couple little solder blobs in that practice area. So again, if you've never soldered before, use this practice area. If during the solder lab, if I come in and I see a bunch of bad solders and lifted traces, lifted pads over here where you've destroyed and you put too much heat, and I come over here and I look and there's nothing in this practice area, I'm going to be a little upset that you didn't practice first before you went in and tried to solder. Okay, so if you've never done this, use the practice area, get those done, and then ask me. Ask if that's a good solder joint before you go trying to actually solder some of the components. Now let's talk about these other components. The rest of the stuff in this package, okay, includes a couple of transistors. That is a transistor. It's got 3 leads on it. And then the package, if you look at it, it's got a flat side. When you look at the area on the component side of this board, you can see that Q1 and Q2, the little silk screen, the little white line in there, has the outline where it shows where the flat side is. So you know how to insert that transistor into those 3 holes. There shouldn't be a question about which hole is which because of the flat side of the silk screen and the flat side of the actual device. The LEDs are the same way, but there's a little bit harder to see. When you look at the silk screen, the LED 1 and 2, there's a flat side, okay? And that tells you which lead goes where. LEDs are definitely polarized, and you got to orient them the right way, especially the LEDs, because there's only 2 holes, and it's very easy to put it in the wrong way. You got a 50-50 chance if you just guess at it, right? But there is a flat side on the silk screen. If you look very, very closely, there is also a flat side around the little ring of the LED. It's kind of hard to see. You got to look at it really close. All right? But make sure you decide which is the flat edge, and maybe Google it. Which lead of the LED is the anode and which is the cathode? There is a longer lead, and it has meaning. It means it's one or the other. I'll let you Google that and decide. For the capacitors are on the paper strip here below the resistors. There are two what are called ceramic capacitors. They're little tiny orange, look like little tiny aspirin tablets. Okay, and they have two leads. That's C4 and C5. They're both the same value, so it doesn't matter which one. They're both 0.02 microfarad capacitors. Okay, and it doesn't matter which way they go in. They're not polarized. Okay, the other ones, the C1, C2, C3, and where is it? There's 4 electrolytic capacitors here. Where am I seeing it? C1, C2, C3. Trying to find the other one. I think there's 4 on here somewhere. I'm missing one. I'm not seeing it right now. But those electrolytic capacitors, these ones that are the little blue cans, we call them, they have a dash on one side. That is the negative terminal. That dash right there is the negative terminal of the device. It's a 2-terminal device, and when you look at the silk screen, there's a plus and minus on there. Make sure you orient it correctly. It's got to be polarized. These are called polarized devices, so it matters which way you turn the device. Finally on here, there's this IC. It's labeled IC1. It's a 555 timer. It has 8 pins on it, as you see. It's in the little plastic pink styrofoam. Okay, it's plugged in there. You got to take it out of the styrofoam, plug it in there, and then solder those 8 pins on the back of it. That's a little bit delicate. They're kind of close together, and it's a little bit of a delicate operation because you can't. It's not one big glob of solder on all 4 of those. It's 8 individual globs, 8 individual. I shouldn't say globs. 8 individual neat solder points, and none of them are connected together. And if you do it right. Again, do the practice stuff. If you do it right with the proper technique, they won't be shorted together. But it shouldn't be a one solid glob across those 4 pins. Okay. The other thing about this IC is it is polarized as well. If you look really closely at the top of this plastic, there's a little dot on the top left corner. Okay, and that dot is indicated on the silk screen too. There's a little dot there at pin 1. That top left pin is pin 1. So it's very easy to turn this 180 degrees and put it in backwards. Don't do that. Right? What else? Then the other thing is there is a speaker that comes with this thing. There's a speaker. On the speaker there are some rings here. And even though it says plus and minus on there, those 2 rings, speakers are not actually polarized, not technically, at least not for this purposes. And the speaker wire's got to be connected right there. So how do we get this speaker connected there? Well, you've got to strip off some of the wire and make the connection. So you've got to strip away a little bit of wire, solder the end of that wire right there, strip away the insulation, wrap the metal of the wire through that loop, and make a solder joint. Then the other end, again, strip it away. It'll go through that hole where it says speaker and soldered on the solder side right there. Okay, and then finally there is power. Right there, there's the battery symbol right there between those 2 points, the plus and the minus. The kit comes with a 9-volt battery connector. So this has got to go through there. It's already stripped away. That's kind of a very delicate wire. So the black lead goes through the negative terminal, red goes through the positive, and then of course you got it on the component on the solder side, solder that down. Okay, I've got a 9-volt battery to test out the circuit. Finally, the other big component is a volume knob. There's a little knob right here. This is a potentiometer. It's got 3 pins on it. It goes right there where it says volume. There's actually 5 holes there, but if you look at the way this thing is oriented, it can really only go in one way. So it goes in like that, and then of course on the solder side you solder those 3. And those other 2 holes are just left. There's nothing that goes in there. All right. I think that's about it. Again, when you get in here, if you've never soldered before, start with this practice area. I'm going to go through the setup of the soldering iron and making sure that the tip is right and it's tinned properly and that everything is good. But you have this handout on the wiki page. Please read through that handout, especially page 6. We will go through, there's also, let me switch over to it. There's also some good stuff in this handout about what is a good solder connection, what is a bad solder connection. I think it's actually on page 10 of the handout. what a good soldering joint looks like. You can kind of see the resistor on the bottom side coming up through, and here's a good technique where the iron is coming in, it's making contact with the pad on the board and the lead at the same time, okay? And the solder comes in from the other side, and you push it in, and it makes a big little volcano-like connection. And that's what it looks like. You know, it's a good connection all the way around the pad, and that's what a good solder connection looks like. What you shouldn't do, here's showing what you should not do. You should not bring the soldering iron coming in and touching just the lead. This is the soldering iron coming in, it's touching just the lead, but it's not touching the pad. What's going to happen is the solder is going to melt on the lead, and it's not going to be connected to the pad. You won't have a good connection there. Also, the solder, when you look at the solder side of the board, it should be going all the way around that pad. That pad is that circular area, right? You shouldn't have too much. We'll go through some other things. Again, it's a very easy thing to do. Those of you who haven't done it before just need a little bit of practice. Once you get one good one, it'll make sense, and you'll be just fine. Okay. So I think I'm going to leave it at that, since my computer is going to run out of battery power soon. Look forward to seeing you in Solder Lab.